Hey everyone, welcome to another video in our series on congruence and transformations. Now, we talked a little bit about congruence in the previous video. We defined it for any figures, any shapes. Now we're going to take a deeper dive into this idea of congruence, and we're going to talk about this particularly with triangles. And this is going to form the building blocks for a lot of later years in which we're going to look towards actually proving congruence and writing out our proofs. We don't have to worry about that now, but I want to introduce you in this video. It's going to be a long one, so just keep that in mind. I want to introduce you to the type of rigor that we require when making any claims in maths. And congruence and this idea of proof writing really forms the basis for a lot of this stuff. What makes triangles identical? What makes anything identical? And this question that I've written at the top of the page here is actually going to be a really important thing that we talk about. And this idea extends beyond maths to ideas of truth. How do we prove something? And this question is, how much information is enough to say that two triangles are identical? Now, to some of you, this may be trivial. Some of you may say, oh, I can just look at them. They kind of look the same, whatever. But what makes these two triangles identical? What are the pieces of information we require? Now, to do this, to run you through this little thought experiment, I'm going to switch over to Jamboard here, and I have two triangles here. Now, how can we say for sure that they're the same? Well, first of all, we can say that they look like they're roughly the same size, but this one on the left is in a different orientation to the one on the right. So, okay, we can apply one of the transformations to one of the triangles. We can say, okay, this one on the right, what if I were to perform a rotation to get it to the same orientation as the first one? Okay, they're starting to look similar, but how do we know? What is it about these two triangles? Although they look the same, sure, but how can we say for sure that they're identical? Well, one thing we can think to do, and you can pause this video and reflect, really think on this stuff deeply because it's going to form the basis for the rest of this topic. One thing we can do when we say that any two things are the same, well, we have to say, okay, they're the same size. All right. And because congruence is this idea of one thing is the exact same size as another thing. So what if we went ahead, we got a ruler, we measured the length down here. And we said, okay, this one is going to be, I don't know, 3 centimeters, and this one was 3 centimeters as well. We measured that and we said, okay, well, one of the sides, one pair of corresponding sides are the same. So, okay, let's just go ahead and mark this and say, okay, well, this side is equal to this side. They're the same. But one side isn't enough to say that two triangles are equal. We still need to consider another two sides. There are 3 sides that make up a triangle. So we would need to say, okay, not only do I have this side being equal, I need another pair of sides being equal. So we go ahead, we measure this, we get that that's, I don't know, 4 centimeters. And we measure this one to be 4 centimeters as well. Okay, now we have another pair of equal sides. So I'm going to mark that here using these lines to show that these two corresponding sides are equal. And once again, I would need to do the same for a third side. Two sides aren't enough to say that something's identical, to say that triangles are identical. We need all three sides to be the same. So you get any two triangles, say you cut them out on a sheet of paper, you would need to know for certain that, or to say for certain that these are identical, you would need to measure all three sides. Only then can you make this conclusion that, okay, cool, now we can say that these are identical. That forms the building blocks for making any statement that we say is true. We need to gather evidence, and that is what we're doing here. And this will hopefully come to you as quite an intuitive idea. If I were to ask you, I gave you two triangles that I cut out. Well, what makes these two the same? You're going to say, well, the first most obvious thing is going to be, I want all the sides to be equal. That's the way I for sure know that these are the same. And if I measure the sides, I can then figure out the area, and then it all follows on from there. So this is the first proof, the first test, we're going to call it, to decide if two triangles are congruent. So I'm going to write a little bit down here on congruence tests. Whoops. And these are these little tests that tell us whether two triangles are identical. This first one is that three sides of the angle are equal to three sides of another triangle. And this test is called side, 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 or SSS for short. So once again, that means that each one of these sides will need to be equal for us to say that these two are identical. But what would happen, for example, if we took out one of those sides, if we didn't know the measurement of one of our sides? So let's say I rubbed out this one and this one here. This is the same side that I've rubbed out. And what if we didn't know those were equal? And what if in some universe we weren't able to measure this to see that they were equal? What if instead we could only measure, what if we got to two sides and someone needed to borrow our ruler, but we had a protractor on us? And what if with that protractor we measured that this angle was the same as this angle here? Now, we're going to need to take a minute to think about, well, how do sides and angles relate to each other in triangles? Now, how do we define an angle? Well, an angle is just the distance between two lines that join together. So I have these two arms of an angle, we call those, and I have the angle marking here. And if I stretched, for example, a wire from here over to here, well, that's got some type of length to it. Now, what if I made the distance between the sides even bigger? What if I made it an obtuse angle? Well, the distance between that is going to get bigger. As an angle gets bigger, the side opposite it of a triangle also gets bigger. Now, if that line became smaller, for example, if that angle became smaller, I should say, what about here? Well, that side is going to get smaller as well. Now, we've established here that the size of an angle relates a lot to the length of the side opposite it. So by that logic, if we had the same angular separation between these two lines and these two lines, what does that allow us to say about the side here? Well, if these two angles are the same size, if the separation between these two arms is the same size, that angle, that distance between, the opposite side is going to be equal as well. So knowing about the angles of a triangle actually tells us a lot about the sides of a triangle as well. And having equal angles tells us that an equal side. Having two equal angles tells us that we have two, let me write it here, two equal sides. Here and here. Now that's pretty useful because now when we don't have if we don't have a side, but we know the angle is equal, we can therefore conclude that the sides then must be equal. So this brings us to another congruence test. And this is what we call side angle side. We call that SAS. Okay, side angle side is now enough to tell us something because everything here, and you're going to learn this as we go on, everything always reduces back to side, side, side. Knowing about these angles and adding these extra elements that we're doing now, they are going to always reduce us back to this idea that to say that two triangles are the same, their sides must be equal. But now we're just substituting one of the sides for an angle. Now, I get this from my students sometimes. They ask me this question. They go, well, why is it side angle side? Why have you written this angle in the middle? Is that just like, have you done that on purpose? Why isn't it side, side angle or angle, side, side? Well, there's actually a reason for this. This isn't just some arbitrary order that I've picked. There's something important about the angle's positioning in the triangle, about which angle we are actually being given. So let's go back to our two pictures up here. Notice that the two angles, this one and this one, notice that both of these angles fall in between the two given sides we had. It's between this side and this side. Between the side we're given, between the side we're given. Notice how, if we were to look at this with all of the elements we know, we would have side, angle, and side. Same with here, we'd have side, angle, side. The angle that we require is the one in between the two ones we're given. Now, why is that? Well, the angle in between, we call this actually the included angle. Matt, so it must be, the angle we need must be the included angle. So this is the angle between two given sides. Two sides that we know are equal. Now, why are we looking at this one? Well, if we, for example, did not choose this angle, let's say this we did, instead of this angle, let me rub this out. Instead of this angle, we picked let's clean this up a bit. Instead, we picked another angle. We picked, I don't know, this one here and this one here. Why wouldn't this be enough? Well, why is it not this angle? Why did it have to be the one here and here? Well, this angle, and as well as this angle, these two oppose a side that we already know is equal. So this particular angle tells us actually nothing new, any new piece of information. It tells us nothing about the unknown side that we require. It's redundant. It doesn't tell us anything new. Sure, we already know that this angle is going to be the same. We already know that these two are identical because we know that, well, their sides are identical already. So we're not actually being given any new information because remember how I said before, all of this reduces back to side, side, side. We want to know something about this side and this side. And the only thing that's going to tell us about that is the included angle, this one in between here. Because if we know that, because equal sides correspond, as we saw before, they correspond to equal angles. So in order to find out about my unknown sides, I need to know that the angle opposite them is the same. So we need the included angle here. That is why when we're looking for ways to prove that triangles are congruent, we need to know, if we don't know anything about that third side, the angle opposing that third side, so this one here, that's going to tell us about them being equal. So that's why we include the one in the middle. So that's why the side angle side, that angle is in the middle. It's written like that so you can kind of remember it. It makes it easier for you to remember because of what we were looking at before here. If we read this from one end to the other, we would read this as side angle side, side angle side. The angle is always going to be in the middle, just with how our eyes end up seeing this. Okay, now let's look a little further. We've done 2 out of the 4 we're going to do in this video. Now, if you're still with me, I really appreciate that. I'm taking a bit longer with it because I really want to draw you guys towards this idea that about the type of rigor that needs to go into saying something is true, into saying 2 things are identical. More goes into it than we realize. So let's look at our 2 triangles again. Now, what if we stripped away another side? Okay, so we were only given information about one side being equal. And let's say we measure one side and someone says, oh, hey, I need that ruler. But you have your trustworthy protractor with you. And you measured, okay, this angle and this angle is equal to this angle and this angle. Would this be enough to say that these two are equal? Well, what we established in the previous example was the sides opposing angles are equal. Because this angle is equal to this one, the sides opposite that angle must be equal as well. So this side is in fact going to be equal to this one. Remember, guys, I'm always reducing this back to side, 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 because that's the most reliable thing to tell us that something is the same. The 2 triangles are the exact same size, that they are identical. Now, pause here. you may be looking at me and going, well, we're looking at this and saying, well, didn't you just say that this one isn't going to work, right? Because it's telling us something redundant that we already know. But we're saying, okay, well, I already know these two are equal. Why is it enough to say that it's this particular angle and not, say, this one here? Well, think back to what we know about angle geometry back from year 7. We know that the angle sum of a triangle, all the angles within a triangle add up to 180 degrees. So if we have two angles that are equal in the triangle, then the third one has to be equal because they're all going to add up to the same angle sum. So just by having two, it doesn't matter what two, that's enough to tell us that our third angle is equal. Because these two bits of information, given two angles of a triangle being the same, we know the third is going to be the same because they add up to the same amount. All triangles add up to 180 degrees. So now we know that these angles are the same. And then we can make the conclusion that, well, okay, this and this must be equal because the sides opposing equal angles are equal as well. So we can say this is the same as that. I've reduced this back to side, side, side every single time. So with given two angles and a side, we can deduce that these two triangles are congruent by just being given any two angles, because we know the third is going to be equal as well. So we can say that another proof for congruence is that when we are given an angle, another angle, and a side, this is enough to prove that two triangles are identical. Now, there's no real trick or rule as to why we have angle, angle, side, why they're written first. This is just convention when we do our proof writing. All right. Thank you for sticking with me. We've got one more. And you may realize that we neglected one particular family of triangles in doing these. All the triangles I drew were these random ones like this. Some were scalenes, some were isosceles. Notice that we forgot to talk about right angle triangles. We have neglected these so far, and I've drawn these different sizes. That's annoying. Let me do that again. Here. Okay, that looks a bit better. We've neglected right angle triangles, but we can still do a lot to prove, we have ways to prove that right angle triangles are identical as well. We still have the tools. Now, right angle triangles, they have a very specific thing we can do from them. They have a relationship between their sides, and you may remember it from a previous video. Pythagoras' theorem tells us certain things about right angle triangles. It tells us that we can find any side if given two. So, if I have a right angle in each, I know they're right angle triangles. I know I can use Pythagoras' theorem. So if this particular side, if these are equal, this is what we call the hypotenuse, if you remember. This is the angles, the side opposite the right angle. If we are given the hypotenuse being equal and another pair of sides being equal, that is enough to say that this final pair of sides are equal. Now, why is that? Well, because we can use Pythagoras' theorem to find the third side. And if two sides are equal, as well as it being a right angle, so the condition for us to even use this theorem in the first place, we can say that these final two pairs of sides are equal. And that is our final test for congruence. This is the test. We call this RHS. So this is right angle, hypotenuse, and side. And we write this as RHS. Now, this is the final proof we have. Let me just ask you one question. This is just for you to think about at home. Something for you to ponder about when you, in your spare time, if you want. Something before we go into our next topic in this series. Why wouldn't angle, angle, angle be a proof of congruence? Something to think about. We've used side, side, side. We've used angle, angle, side. We've used side, angle, side. Why isn't angle, angle, angle the same? Because we looked at something in particular. We said, all right, well, we know that the opposite sides opposite angles being equal are equal. Why wouldn't angle, angle, angle work for proving congruence? Just something to think about at home before we attempt a couple of questions here. So try to go through these really quickly because I'm sure I've gone over time. I want to look at question A. We want to write which of these tests would be used to test the congruence of these pairs of triangles. Now, all this is a matter of is just locating what information we've been given and writing which proof then tells us that they're the same. So if you've really understood what we've talked about so far, you shouldn't have too much of a problem with these ones. Now, let's just look at what we've been given. We've been given a pair of equal angles, given another pair of equal angles, and we've been given a pair of equal sides. What do we have here? We have two angles and a side. That's all we're doing at this stage. We're just looking at what we're given and looking at the tools we have for proving congruence and then just stating what that would be. So that's all there is to part A. Now, part B, what pieces of information are we given? Okay, we've got two equal angles here. Now, these are right angles. Already you can hopefully see the hint here, but let's just keep going. Let's assume we haven't picked up on anything yet. We have another pair of equal sides, and we also have that the hypotenuse, the side opposing my right angle, those are equal too. So we have a side, a right angle, and a hypotenuse. So clearly we're going to be using RHS. We have RHS. Thank you so much for joining me, guys. I'll catch you in the next video.